Here we're going to take another look at how we can graph linear functions and another process involved with that. So on the graph that we have seen here, we have the graph of f of x, also known as f of x of 2x, also known as y equals 2x. And we've graphed it by finding some ordered pair coordinates, such as x equals 1 and evaluating to get 2, when x equals 0, and then when x equals -1. So we have these 3 points plotted on this function. Let's go ahead and also do the same thing and graph g of x. G of x equals 2x plus 3. And we can look and see that we have a relationship here that g of x is just what we have for f of x plus 2. So we can think of g of x as f of x plus 3, because f of x is just 2x. And since we know that f of x has these values listed here, in order to plot g of x, we just need to take those values and add 3. So in order to evaluate f of 1, we can take f of x, which is 2, and add 3 to get 5. And so we have this new point, 1, 5. We can do the same thing with g of 0 equals 2 plus 3. 0 plus 3, which equals 3, because f of x is 0. And we have this new point here. And we can do it again with g of -1. Well, f of -1 is -2 plus 3 equals 1. And so we have the point -1, 1. And we can graph our line, connect our points. And what we see here is that because g of x is f of x plus 3, all the points on the line of g of x are 3 units shifted above f of x. So g of x is f of x shifted 3 units up. And so we can see that comparison. And we'll talk more about this in an upcoming section. This is an introduction to what we call transformations of functions. We're going to look at that more coming up again. So recall that we can graph using intercepts. The definition that we gave earlier for x-intercepts is that it is the point where the graph crosses the x-axis. And every point on the x-axis, we look at a coordinate grid, every point that crosses the x-axis, no matter what our line is, no matter what the slope is, every point on the x-axis has the same thing in common. Its y value is 0, because it's no movement vertically on the y-axis. So to find an x-intercept, we let y equal 0. If we're dealing with function notation, we would have f of x equal 0. And once we solve, or we plug in y for 0, we then have to just solve for x. Conversely, every y-intercept, no matter what the line is, every y-intercept has the same feature, where all the x values are 0, regardless of the y value, because there's no horizontal movement on the x-axis. So to find a y-intercept, we let x equal 0, and we solve for y. If we're in function notation, we're evaluating for f of 0 and solving for f of 0. So the following questions want us to find the intercepts and then graph using those provided intercepts. When we're using intercepts, it's always a good idea to calculate a third point to check to make sure our graph is good. So we'll start with our x-intercept. Alright, so for the x-intercept, we want to let y equal 0. Let y equal 0. In this case, f of x. So we're replacing f of x with 0, and we are solving for x. We add 6, divide by 3, x equals 2, giving us an ordered pair of 2, 0. X was 2, y was 0. We have our ordered pair 2, 0. Now let's go ahead and find our y-intercept. We're going to let x equal 0. So we will evaluate for f of 0. 3 times 0 minus 6. That means f of 0 equals negative 6. So we have our ordered pair, negative 6, comma 0. 0, negative 6. 0, negative 6. X was 0 and evaluated it to negative 6. And so we have those 2 points. We have the points 2, 0 and negative 6. 0, negative 6. Now let's use a third point to kind of check our solution. We'll call that a checkpoint. Checkpoint. So we could say any value of x other than 2 or 0. So what about if x is 1? Let x equal 1. So we'll evaluate f of 1. 3 times 1 minus 6. F of 1 equals negative 3. So we have the ordered pair, 1, negative 3. And we plot that and we see that all 3 points are in line. So we know that we did it correctly. We got the correct intercepts for x and y. Let's go ahead and graph the next one. We'll make this a blue line. So let's start with our x-intercept. Again, we let y equal 0. So 3x plus 4 times 0 equals negative 12. 4 times 0 is 0, so this term essentially eliminates. X equals negative 4. So we have the ordered pair, negative 4, comma 0. Let's get our y-intercept. Again, we let x equal 0. This term eliminates. Y equals negative 3. So we have the ordered pair 0, negative 3. And then let's go ahead and find a checkpoint. So let's say x equals 1. Let's try x equals 1. 3 times 1 plus 4x or 4y equals negative 12. So we don't get a whole number, but we can make sure that it's still close to our answer. So we have 1 and negative 15/4, which is approximately 3 1/4, which is 3 1/4, negative 3 1/4. So we can make sure that that falls where we expect it to. So we'll go ahead and graph our intercepts, negative 4, 0, and 0, negative 3. And if we connect those lines, and we'll see if our checkpoint makes sense. So we graph that, and we see, okay, so at 1, and then negative 15/4, negative 3 1/4, that lines up with our expectation right about, I don't know what I put on that line, right about there. So that does match up with the 1 and negative 3 1/4, or 3 3/4. So there our checkpoint works, and we know our line is correct. Let's go ahead and find one more. Let's make this line, let's do purple. So we will start with our x-intercept, where y equals 0. So x equals 0. We have the ordered pair 0, 0. Well, if we're trying to find our y-intercept, 0, 0. Our y-intercept is when x equals 0. And what we see here, x already equals 0. So 0, 0 is both the x-intercept and the y-intercept. So we have to find a second and ideally a third point to make sure that we're graphing this line correctly, because our x and y-intercept are the same point. Whenever our intercept is the origin, that is on the x and the y-axis. So your x and y-intercepts will be the same. So the y-intercept is also 0, 0. So let's use a checkpoint. And we'll actually do 2. This is a good idea to have 3 points. So first, let's let x equal something easy to solve for, like 4. We can use any value for x. I can just look and see that if x is 4, it'll be a lot easier to solve. Hopefully you'll see why in a second as well. If 4 equals negative 2y, we divide by negative 2, we get y equals negative 2 for the point 4, negative 2. And then let's pick a value of y this time. Let's let y equal 1, something that we don't have already. So x equals negative 2 times 1. So x equals negative 2. So we have the ordered pair, negative 2, 1. And we can plot these. So we have the point 4, 2. And then we also have the point negative 2, 1. And when we go ahead and line those up, we see, yep, they do line up. We are good. There is our last linear equation. So that was line C. And we had line B. And our first one, which was line A.